Hi, my name is Morgan Lynn, and I go to St. Vincent Ferrer High School in New York.
And I'm Tobi Sakin. I go to Roosevelt High School in San Antonio, Texas.
And today we are presenting variations in air quality within New York City.
We'll be looking at differences in air quality within the urban and suburban areas of the New York Metro.
Before we get into our data, let's look at our air quality background. Air quality is a diverse field of science studying polluted and unpolluted air and its impacts on human health. For our study, we looked at particulate matter at the 2.5 micron level from purple air, visibility at the ground level, and wind speed and direction.
So our research question was, how does air quality of urban areas differ from the air quality of suburban areas in the New York Metro? And what factors could contribute to those differences in air quality in the New York Metro?
And for our methodology, we looked at our background research, then we formulated our hypothesis and research plan. We found suitable purple air sensors in NOAA stations for data collection, compiled purple air PM2.5 data and local climatological data from NOAA, and we finally generated graphs using Google Sheets and Igor Pro for data analysis.
So our hypothesis was based off a 2008 CDC study comparing urban metropolitan counties to surrounding suburban counties, and they found that air quality in the suburban counties was shown to be better than the urban counties. A 2020 study in China found similar results in the multiple cities. So with this, we hypothesized that the urban areas of the New York Metro experience greater levels of 2.5, in addition to poor visibility compared to the suburban areas.
And here is a map configured by our GIS of the purple air sensors we used. The urban areas we looked at were the Metropolitan Correctional Center, New York Metropolitan Transit, and Central Park. So they're really close proximity to each other. For our suburban areas, we looked at Newark Liberty International Airport, Westchester, and Farmingdale. So let's look at our urban areas. For the data we collected, we compared Central Park versus Metropolitan Center and Transit. And what we found was that there were similar peaks during wildfire week, which was from June 6th to June 11th, when New York was most directly impacted by the Canadian wildfires. So we see that New York Metropolitan Transit had the greatest peak.
We see this in the NOAA visibility data, that the peaks were found to be during the wildfire week and towards the end of the month. We found that Central Park peaked more frequently and before all the other urban areas, possibly due to Central Park being a very busy part of New York in the Manhattan area.
Now let's look at our suburban areas. For Newark, we see a strong correspondence between the visibility data and the PM2.5 data. As we can see, we see a similar peak to the urban areas during wildfire week, and this corresponds to our NOAA data, where we see really low visibility. So this goes for the same in Westchester and Farmingdale. Now we can compare Farmingdale versus Newark and Westchester, and Newark Liberty International Airport has the greatest peak during wildfire week, showing greatest PM2.5 concentration, which means it had the lowest air quality during this time. And now let's draw some comparisons. So when we compare our data gathered from our urban areas versus our suburban areas are labeled in red, urban areas are labeled in blue. This kind of goes against our hypothesis. We believe that our urban areas would have worse air quality compared to our suburban areas because it's more industrialized and busy. But we found out that our suburban areas actually have a greater peak during wildfire week and greater peaks throughout the month of June. And this corresponds to our visibility data. So suburban areas generally show lower visibility than urban areas.
The prevailing wind direction was northwest for the week of the wildfire week, so the wind could explain why New York had higher PM2.5 concentrations compared to other suburbs, and why Farmingdale had the least.
For our analysis, we can see again that on June 7th to 8th, there's a significant increase in PM2.5 levels in both urban and suburban areas. And this is emphasized on our various peak dates, June 1st to 6th, June 7th to 8th, June 18th, and June 26th, and so on.
No visibility data corresponds with this. On all those days, we saw very significant spikes in poor visibility, meaning that the Canadian wildfires generally had a very drastic effect on bad air quality in the whole New York metro area. Wind direction also could have played a role in spreading pollutants from the urban areas to surrounding suburbs, and smaller spikes in pore visibility prior to the wildfires and after the wildfires could be from other sources like industrial plants, car emissions, and possibly construction due to New York being very busy city.
For our conclusions and further expansion, we looked at an article, and basically what we gathered from this article was that a lot of the greater PM2.5 concentrations in our suburban areas can be attributed to the greater amount of like factories, plant vehicles, and other machinery that is causing wind to pick up more emissions from these factories and plants, as stated in this article.
Further research using a larger time scale, longer than a month that we used, as well as looking to more surrounding suburbs, could provide more information about this phenomenon. In addition, studies into other large cities around the world, such as Paris, London, Beijing, could be used to draw conclusions about air quality in other large metros.
Here is our literature review and citations and other sources for data collection, and we would like to thank all of our mentors and NASACs. Thank you so much.
Thank you.